To find the inverse of a 3 by 3 matrix, we have to use a process that works for any square matrix. And the process I'm going to show you works for a 2 by 2 matrix as well. So if you can't remember the formula, special formula for a 2 by 2 matrix, that's fine. You'll be able to do this process here. The process is we take the matrix and we augment it with the identity matrix. And then we do row operations to try to turn A into the identity. And we do row operations to the entire thing, which means we're changing this identity on the right as we go as well. And once we get to the identity on the left, the right side will be the inverse of A. So let's go ahead and do that. We've got our matrix A, and we augment it with the identity matrix. And it just is going to be the identity that's the same size as A. And then we want to do row operations to turn this into the identity. So I'm going to go ahead and start just by getting some zeros down here. So to get rid of this 3, I'm going to use the 2 above it. I'm going to take 2 times row 2. That'll give me a 6 right here. And 3 times row 1, that'll give me a 6 right there. And then I can subtract them, and that will be my new row 2. So my first row, I'm going to go ahead and leave the way it is. I get 6 minus 6 is 0. Okay. 6 minus 9, which is negative 3. 2 minus 3, which is negative 1. 0 minus 3 is negative 3. 2 minus 0 is 2. And 0 minus 0 is 0. I can get rid of this 2 in the third row by just subtracting those 2 rows. Okay, row 3 minus row 1. That will be our new row 3. 2 minus 2 is 0. 4 minus 3 is 1. 1 minus 1 is 0. 0 minus 1 is negative 1. 0 minus 0 is 0. And 1 minus 0 is 1. All right. Notice that I've already got here a 1 in the second column. And I know I'm going to want a 1 in this spot right here. So I can just flip these 2 rows around. The second and the third rows, I'm just going to go ahead and swap positions there. Because that'll make it a little bit easier, already having that 1 there. So my first row stays the same. Now my second row I take my third row and put it up there, and that second row I move down. Okay, so now I've got that 1 there, and I can easily use that 1 to get rid of the negative 3 below. So I'll take row 3, which has a negative 3 there, and add 3 of row 2. That will be my new row 3. So my first row stays the same. My second row stays the same. And for my third row, I have 0 plus 0 is 0. Negative 3 plus 3 is 0. Negative 1 plus 0 is negative 1. Negative 3 plus negative 3 is negative 6. 2 plus 0 is 2. And 0 plus 3 is 3. All right, well now I've got my zeros down below where I want. I know that I'm going to want 1s along the diagonal, and I'm going to want 0s above that. I like to get my 0s first, and not instead of forcing the 1s. And so I can do each one of these. I'm going to go in order here. I'm going to get rid of this 1 here. So I'm going to take row 1, and if I add row 3 to it, that'll give me a 0 there. So plus row 3, that'll give me my new row 1. So 2 plus 0 is 2, 3 plus 0 is 3, 1 plus negative 1 is 0, 1 plus negative 6 is negative 5, 0 plus 2 is 2, and 0 plus 3 is 3. My second row is already the way it needs to be. I'm going to go ahead and multiply the third row by a negative 1, because I know I'm going to need that to be a 1 instead of negative 1. So it flips the sign on everything there. And we're good now with our third row. Okay, we can also get rid of this 3 by subtracting 3 of row 2. So row 1 minus 3 times row 2 will be our new, row 1. So 2 minus 0 is 2. 3 minus 3 is 0. 0 minus 0 is 0. Negative 5 minus negative 3 is negative 2. 2 minus 0 is 2. And 3 minus 3 is 0. And my second row stays the same, and my third row stays the same. Now I'm almost there. The last thing I need is for my first row, I need a 1 right there. So we'll go ahead and just multiply our first row by 1/2. 1/2 times row 1 will be our new row 1. That's 1, 0, 0, negative 1, 1, 0. And my second row stays the same. And my third row stays the same. Now that was a lot of work. But once you get your inverse there on the left, the identity on the left, once you get the identity matrix on the left, the right side is the inverse. And so I'm going to go ahead and just copy this copy, and then we'll come up here. Okay, and we've got our matrix A here, and I can paste what I just got. Just say that right there is A inverse. Okay, and you can of course check that this is the inverse, that your answer is correct by multiplying these two matrices. You can take that first row times that first column. And I'll go ahead and let you do that. I'm not going to go through that. I happen to know that this is the correct inverse.